My session is Divide and Conquer, Send Forth the Microservices. My name is Jennifer Reif. My contact information is there in the lower left-hand side. This will be a pretty snug presentation. I'm writing a lot of code, demoing a lot of code for you guys. So I will get to questions at the end. I'll be sure to check back in the chat and be sure to answer those. But we'll just kind of charge on through for the session time. I'm a developer and advocate at Neo4j. I enjoy learning technology, and then I like sharing technology in a variety of different ways. So whether that's through writing blog posts or creating videos or speaking at virtual or in-person events, such as this one, I'm happy to do that. And I just really enjoy sharing and talking tech with others out there. Again, my contact info is there in the lower left. It'll also be on the final slide. So if you think of something after the event is over, for some reason can't reach me within the event in the next couple of days, feel free to contact me. Any one of those methods you're most comfortable with. I'm happy to continue the conversation about tech, Neo4j, and such. So I would be remiss if I talked microservices and didn't mention kind of the alternative or kind of maybe the contrast to that. So most people, when you talk about microservices, the opposite of that is going to be something like a monolith. And this is typically when you bundle multiple functionalities or maybe capabilities or functions or features inside a single application. This can be designed intentionally, or sometimes it just morphs into that over time, right? We're all familiar with tech projects. They may start really small and then all of a sudden, oh, let's add this and let's add that. And pretty soon you have this gigantic monstrosity. So it can happen either of those ways, whether intentional or unintentional. And if any of you recognize the image there on the right-hand side, that is from Lord of the Rings. I kind of like to think of monoliths as kind of this big, imposing fortress. So this is Helm's Deep from the Lord of the Rings series. So maybe not the most movable, but definitely has its place in certain contexts and in certain situations. So the good sides with a monolith are that you kind of have this one and done package, if you will. So whether you're dealing with, binaries or RPMs or jars or what have you, you kind of have this one and done type of approach when you're dealing with kind of pieces to implement. There's less communication because everything can kind of communicate within the same package, right? Or same classes potentially. The downsides to this is finding and reusing code can be quite complex. Implementing fixes, you could potentially impact other pieces of the application. Resource consumption, so especially when you're talking about scaling up, scaling down, maybe storage or just bandwidth size to implement the package itself. And then handling failures is trickier as well. So if some piece of the application is down, it's very likely that you could have the whole entire application down, which is not always the best when you're talking resiliency. So on the flip side of that, microservices tend to be small applications for either a single functionality or even limited functionality. And you'll have different people kind of vary on how strict they are in their definition of microservices. But basically, microservices try to deal with only necessary communication. So you're not bundling a bunch of classes into a single application when maybe those classes don't need to communicate with one another. You'll only have maybe service A only needs to connect to service C, service B connects to C, D, and E, and so on. So you'll only connect those wires that need connecting. The good side to this is that microservices tend to be very independent. They have a small footprint because they're typically small applications, small jars, binaries, etc. And this is very reliable and scalable. So you can kind of spin up, spin down, add additional services without increasing kind of your load or your overall system structure. So I like to think of these as more kind of battle units, and then you can see that kind of image on the right-hand side. So this is the battle units from Lord of the Rings as well, the campaign for Middle-earth. And so you have these small individual groups, much more flexible, much more spin up, spin down, kind of wherever you need them, and so on. The downsides with microservices, and there are some, is testing can be a whole lot more complex and tricky, and adding a communication layer. So you need something in order for these services to connect and communicate with one another, ping, send data back and forth, and so on. You're typically adding additional layers for this. So communication layers, maybe configuration layers, operations, and kind of monitoring layers, and so on, that might be a whole lot more complex than what you deal with when you're simply looking at monoliths. Now, I will say, as kind of a disclaimer, neither solution is a silver bullet. You're going to have both simplicity and complexity in either situation. So no matter what you go with, it really just depends on your business need and kind of the risks and things you're willing to take on. Just as kind of a side note, I alluded to this earlier. Different people kind of classify or define microservices slightly differently, depending on the scope of the functionality, whether you're dealing with asynchronous or synchronous communication, and the level of automation you have in the system. So some people will look at a microservices system and say that's not a true microservices system. It's a blend or hybrid of monolith and microservice. And then others will consider it to be a microservices system. So just so you're aware, there's kind of various definitions of what a true microservices system looks like. So we will dive right into demoing now. So we're going to start with kind of a basic, as trimmed down and simplified as an application as possible. And then we'll kind of move up and create different levels here. So we have, we're going to create two applications, one a back end and one a front end. And we're just going to have them toss a string back and forth to, or from one to the other. So we'll have the backend basically be like an API layer, and it's going to provide a string endpoint, and then the front end is going to accept that and show it to the client potentially. Then we'll kind of move on up in our system. We're going to add a Neo4j database on the back end, and this will be handled by Neo4j Aura DB free tier. So that's Neo4j's database as a service offering. And then we do have a free tier for that. So we'll have a database that has book reviews loaded onto it. I loaded a Goodreads data set to it. And then we will have our backend service. It's going to interface with a config service that's going to basically get a hold of the database credentials and then reach out to the Neo4j database in order to pull the data that it needs. And then it'll pass that information on up to the front end service. And then finally, we will add a layer of Docker Compose or orchestration in order to handle startup and shutdown of 3 of our services altogether. The only one that's not included in that is the Neo4j database, because, as I mentioned, it's running on Neo4j's hosted cloud, our database as a service. And so we don't need Docker Compose to handle startup and spin down of that. All right, let's dive in and just code. So I'm going to switch over and we are going to just create a couple of Spring Boot applications. So we're going to go to Spring. I'm going to choose Maven. Java is kind of my preferred language, but any of them are fine, whatever you're most comfortable with. We'll stick with the latest stable version of Spring Boot. I'm going to kind of change the group just for organization of my projects. And then we can change this. Let's just call this backend. We'll stick with the same jar and Java version that's default. And then we need a couple of dependencies. So we're going to add capability in for reactive web. This is going to give us the capability to communicate and build reactive web applications. So this will allow us to transmit data back and forth between our applications and set up for non-blocking reactive communication between them. Now, again, some people will consider only asynchronous communication to be true microservices. Some will consider some synchronous in certain situations still to be microservice. It just really depends. But we're going to go ahead and set this up to be reactive so that we have that non-blocking reactive capability out of the box. Then I'm also going to add Lombok. This is going to cut down some of my boilerplate, reduce the time that I have to sit and write boilerplate code so that we can get to the good stuff faster in the demo. So with that, I'm going to generate this and I'm going to stick it in a folder. And then I'm basically going to create just the same thing, but called a front end. And so we're going to stick with the same dependencies and everything in there. And then I can unzip. And I'm going to unzip the front end as well. And I'll open these in IntelliJ, or at least let's start with our backend application and get this loaded up. And I always like to start with the POM, and it's going to take a couple of seconds to complete loading. But I like to check to make sure that everything I requested from the Spring Initializer actually made it. So stable version of Spring Boot, Java 17. We have our web flux dependency. So that's that reactive web. And we have Lombok. And then it also tosses in a test dependency for us and the reactor dependency as well. That gives us the reactive capabilities. And then we have a Maven plugin that gets included there too. So everything looks good here. Let's jump on into our application.properties. So we have two applications. They're going to run locally. And so we need to have the communication between those to not conflict with one another, right? So we're going to assign different ports to each one. So server.port 8081 for this one. And I like to have the front end application, or what's going to be the client interfacing application, to be the kind of the default of 8080. So that's why I've assigned this odd 8081 over to this backend service here. And then let's dive on down here. And we're just going to start with something kind of run of the mill out of the box. We're just going to call this message controller. So we're going to create a controller class. And then this is going to be a Spring REST controller. We're going to have Lombok create a constructor with all arguments for us so that I don't have to add that boilerplate. And then we want to set up a endpoint for us to hit. So in this case, let's just call it something simple and basic like text. Then we can set up a method a method that's going to have an endpoint for us. And so let's say we're going to return a string. We're going to call this method get text. And then we're just going to return hello world. So again, super straightforward, nothing fancy. And if I go ahead and run this, then I should be able to head over. Oops, it didn't switch over to my browser window. Okay, 1 second. There it goes. Okay. IntelliJ doesn't like it when you try to switch windows when they're in full screen. So 8081. So we set up our endpoint 8081 / our application is at port 8081. Our endpoint is /text. So if I run that, we do in fact see hello world come up, which is what that string that we provided as a return for the method. So, okay, there's application 1. Now, let's switch gears here, and we want to open our front end application. Okay, and I'll go to full screen for this one as well. Again, POM, straightforward, just checking that, made sure everything gets here. Our web flux dependency, our Lombok dependency, our test dependency and reactor dependency, and the Maven plugin. Okay, everything looks good there. Let's jump over to our resources. Now again, we want this port to be different, so we're going to assign it the 8080 port, so that way it doesn't conflict with our backend service on 8081. And then we're going to jump over to our front end application, and we're going to basically create the same thing over here. We're going to create a controller class, but this one is going to accept what the backend is providing. So again, it's REST controller. We're going to have Lombok create a constructor with all arguments, and we're going to set up a request mapping. Let's call this one /hello for our nice client happy endpoint there. Now, we need something in order to accept an HTTP request that's coming from that backend service, right? In order to do that, we're going to set up a bean that's going to use web client, which accepts HTTP requests in a non-blocking fashion, which means that we have reactive capabilities using web client. So we can accept as many requests or as few requests as we set up. Non-blocking means that it's not going to stop them. It's going to let them just kind of stream in. And so we can set this up to have a bean for this, and then we can use that bean in order to grab that backend API and pull the data that's coming back. So we're going to return web client.create, and we want to go to HTTP localhost port 8081. So that's where we're expecting that backend service to live, right? And then we need to inject that. So web client, we're going to call this client. And then we need to use that in a method. So again, we're dealing with reactive types. So we need to specify a mono of string because we're only expecting a single string to come back, right? Just that hello world. And then we can call this get text or get message if we want to, anything we want there. And then we're going to return client dot get dot URI. Remember, port 8081 / text is where our endpoint lives, where that information lives. Dot retrieve body to mono. So it's going to take the body of that HTTP request. It's going to convert it to a mono type, that single element that we're expecting. And we're going to expect a type of string.class to come back. Okay, so everything looks happy. I don't see any red, so that's good. Let's go ahead and run this application now. Oops, for some reason. There we go. I don't know why this message keeps popping up for me. All right, and then let's switch over to our browser. And now I'm going to open a separate tab here so we can kind of flip-flop between the two. Localhost port 8080 / hello. That's our front end application. And you can see now we're getting that same text. So we are able to, from the front end application, grab the back end application or ping that back end application. It provides that text string and it sends it back up to the client application. So everything is working as we expect it to. Now, again, this is nothing super fancy. We're just tossing a string over the wire, right? This is not, maybe to some of you, true microservices. So let's fix that. I'm going to flop back over to the backend service and let's plug in Neo4j to this. So we're going to plug in a database. Now, in order to do that, I've got to add that to my POM. So dependency, I'm going to use Spring Boot Starter Data Neo4j. And this will allow me to use Spring Data, the Spring Data project for Neo4j. Spring Data has a lot of different projects for MongoDB and so on. Now, I also need to plug in details in the application.properties in order to connect to that database. But since I'm running a cloud database, I don't really want to share those. So what I'm going to do is I have a backup application.properties that has that info in there. And I'm just going to copy that in. If you want to see what it actually looks like, the template and so on, that is available in my code repo at the very end. And I will show you guys where that is. But for now, we'll just copy it in there. And that will allow me to connect to my cloud database. It has things like the URI, the username, password, and then the actual database name to connect to. All right. So with that, now we're dealing with book reviews. And so we need to connect our Java entities or our data entities inside Neo4j to our Java application on the front end side. So we're going to create a data class. We're going to call this review. And we're going to use the @data annotation, which is a Lombok annotation that does getter, setters, equals, hashcode, and two-string methods for me. So again, I don't have to write all that boilerplate. We don't have to read through all of that boilerplate. Next, we need to specify that this entity is a entity type in the database. So because we're dealing with Neo4j in the data model schema works with nodes and relationships. So this is a node entity in our database. We need an ID. I'm also using a generated value as the ID. I'm going to start with just the internal ID for the entity. We just call it a kind of a Neo ID, if you will. And then we also need to specify, don't have to, but our basically our technical key or business key, if you will, which is the review ID itself. So the ID that gets assigned to the review. And then we also have the book that it's attached to. So the book that review is for. And we have the actual review text. And then we have the date that it was added. And then finally, we want to keep track of the rating that this reviewer gave for the book. And so we can track that through an integer. Okay, that's our data class. So now we can map our node objects that are reviews to review objects inside our application. Next, we want to be able to interact with the database via a repository. So we can call this review repository. It's going to extend the reactive Neo4j repository. We're dealing with entity types of review that have an ID of long. And we could actually utilize Spring's derived finder methods if we wanted to. They kind of build a few things like find one, find all, and so on out of the box for you that are derived methods. However, we have thousands upon thousands of reviews sitting in our Neo4j database. And because I don't want to overload the browser for demo purposes and overload my internet speed and so on, I'm going to limit this down just a bit. So I'm going to create a method that's going to return a flux of reviews, so multiple reviews. And I'm going to say find first 1000 by. So normally with Spring derived methods, you would provide some sort of criteria. So find first 1000 by name, by title, by author, by rating, so on. However, if you kind of a little hack is if you don't provide a criteria specifically, then it just grabs a random 1000, which is exactly what I wanted, what I was looking for. So we're just going to do that. And then we need to inject that into our controller, our repository into our controller so that we can utilize it. So review repository, and we're just going to call this repo. We're going to return a flux of reviews. We're going to call this get reviews now because that makes more sense. And actually, we could call this endpoint. We're going to a database now, so I'm just going to call it Neo. Again, a little bit more of an alignment with what we're working on now. And then let's say we're going to return repo.find first 1000. That pulls our method, and I think that's all we need here. Let's rerun the application and see where we end up on our endpoint. So flip back over to here. Go back to, again, my /8081, but now remember we've changed this to /neo. And this should now provide reviews. And of course, now I'm too zoomed in. So now we get several reviews coming back. We've got our ID, we have the review ID, the book ID that it's the review is for, the actual text, the date it was added, and the rating. And we can scroll through, but we're going to get 1000, which is what I specified in the method. Okay, this is good, but we haven't actually provided that to the front end. So let's swap over and head back to our front end application and plug this back in. So now we need to add this info. So nothing else needs done there. We just need to plug it in right in our application here. So let's just change this to reviews. Again, we're not dealing with simple text anymore. We're dealing with objects. And we also want a data class here. The reason for that being is we could just deal with a map of data and work with it that way, but it's a little bit cumbersome. The easiest way I have found to work with this data is to create a data class here. And so we can use @data. Again, it handles the getters, setters, equals hash code 2 string for us so that we can access those member variables inside the class. But we don't need to specify the @node because we're not interacting with the database. So this application really doesn't care whether it's a database entity or not. So here we just need to specify, we have a string of Neo ID. We have a string of review ID, and we have some strings for our book ID, our review text, and our date added. And then we have our integer of rating. So that's all we need to provide. Again, just the outline of that class so it maps to our data object here. Now we need to plug this info in. So we're not dealing with a mono anymore. We're dealing with a flux of reviews. And we can just leave that as is, or we can change this to get reviews just so it matches our data a little bit better. We're no longer going to /text. Remember, we are going to /neo. And we're no longer accepting a mono, right? We're going to take the body of that HTTP request and we're going to turn it into a flux. And we're not expecting a string to come back. We're expecting reviews to come back. So without further ado, we can restart that up. Okay, and switch back over to the browser. And 8080, remember now we have our /reviews. And we get our reviews coming back. So now, again, we have that front-end application that pings that back-end API. The API is going to the database and then returning that info kind of in that chain all the way back up to our client application. Okay, now this looks good, but we're still running everything locally, right? We're not having an orchestration service or automation kind of handle this for us. So what we can do is I will switch back over here and stop the applications. That way I don't have anything conflicting when I spin up Docker here. Over to here. So I have a couple of shortcuts that I will walk through. First off, I have another application.properties file for my backend service because I no longer want to have the internal application ping the database. We are actually, as I mentioned and as I kind of showed on that one slide, we're going to use a config server in order to handle the database credentials so that I don't have to share my database credentials within the application itself. So I've modified the application.properties to basically comment out those database credentials. And now I can just set this in to my resources, and I'm going to I'll probably have to delete this and just rename this here. There we go. And then we have a sample Docker file. Now, there are a variety of different ways you can go about orchestration services. I have chosen to go with Docker Compose. And the way that Docker Compose and several other orchestration tools work is you typically spin up Docker containers with the applications in them. So in order to do that, we're going to need a Docker file in order to containerize each one of these. So I'm just going to paste my Docker files in to my services, but I will need to make a tweak in the front end application because I can't use the exact same Docker file. I have to modify it for front end. And same here. Oops, spelling. There we go. Got ahead of myself. Okay, so I'm basically creating a base image, so a container that has Azul's OpenJDK version 17 in it as the base layer. I'm specifying if anybody has questions about this particular Docker file, this is who to contact. And then I'm copying in the jar file for this front-end application as frontend.jar, and I'm exposing that in the container as well. Okay, so with that, we have the Docker file, and then before I forget, let's go ahead and build the jar files. Because if I looked in my target directory for each one of these applications, we actually would not see anything in there. There we go. So let's go into our backend application, and I can do a Maven clean package. And oh, I forgot one other thing too. Let's see here. Okay. So I mentioned that we have the config server that we're going to use the data or to access the database credentials. But in order for the backend application to utilize that to be basically a config client, I need to add that to the POM. So I'm going to add this as a Spring Cloud Starter config, specify a version, reload Maven for that. And now this will kind of default, it's going to be looking for a config server. So now I can switch back over here, and within my backend folder, then I'm going to need to specify a separate option, because now that I've specified it as a config client, it's going to look for a config server running and try to connect to it. Since I don't have config server running locally, it's not going to find one, and it's going to fail that test. So it'll actually fail the build if I don't add this additional option onto the end. But we're going to go ahead and say, okay, we know it's expecting it. We don't have one running. Skip the tests. Obviously, in production or even in real applications, you would want to build a test into that and have a test config server to run against and so on. But this creates our jar file. So now let's go over to our front end and basically do the same thing. However, our client application does not use config server at all. I didn't add that in the POM, so it's not going to look for the config server. Therefore, I can just do a Maven clean package, and that'll build the jar file. It'll run all the tests. You can see in just a second, you'll see some test results that kind of show, yeah, see it there. It's running tests. So it takes a couple extra seconds from what we did on the last one. Okay, so now we should have our jar files ready to go. The only other thing is I will walk through very quickly the Docker Compose file. Open this with, here we go. Now, I could have coded this all from scratch, but who really wants to watch me write YAML code? So if you call it code, I guess, but config file basically. So we need something in order for Docker Compose to use as a template in order to spin these services up and down and to know what to spin up and down and what configurations or environment variables to add. So here we have the version of the Docker Compose file and then the list of services that we want to add. So I mentioned we're going to add a config service in there. We have the container name that is going to specify how we can access this container directly. This is going to run off of an image that I created in Docker Hub. However, you can build it from a local folder or other places, but I've specified it's just going to pull from Docker Hub. The default port for config service is 8088, or 8888, excuse me. So we're going to specify it's going to expose the internal port of 8888 to the external port on the container of 8888. We're setting a couple of different profiles. This you can do if you're running with different environments and you need different values for running test environments versus dev environments and so on. I'm going to mount a couple of volumes on my local machine, one to actually access the config files. You have the option to have config files in a GitHub repository or elsewhere. You can also put them in a local folder for testing purposes. And because I didn't want to expose my credentials on GitHub, I just put them in a local folder. So I need to mount that so that any changes I make locally will get shown in the Docker file or in the Docker container as well. And then I want to mount log files as well so that I can access them outside the container. Docker network, I go into a little bit more specifics in some of my blog posts, but basically Docker will create a default network for you if you don't specify one, but that means that the containers can only talk to one another using IP address. So if you create a custom network, you can actually reference by the container name, which is much easier for me when I'm demoing to remember which container am I going to, instead of trying to remember, okay, which IP address do I need for this particular container. Next, we have our backend and our front end services. Sorry about that. And so our container name, again, this is our reference for the name. So I can ping backend and it's going to grab this service. It's going to build from a local folder that has our application in it. It's going to expose this port and it's going to depend on the config service because obviously our config service has the database credentials that we need. So if it doesn't find the config service or if for some reason the config service is not up, then all of a sudden this service is not going to work. I go into a little bit more detail in my blog post on this as well, but basically if you have some failures within the application, you try to build resiliency into the application itself, but when that kind of hits a wall, then you can actually restart the entire container. And I had some issues with config server specifically on this, and so we could just restart the container here. So it will do that if it finds a failure. Set some environment variables, so it needs to find a particular config file to reference for this application. It needs to know where the config server is located, and I'm using a particular profile of Docker. And then, of course, the custom network that I specified. Same thing, looks really similar on the front end. We're just going to port 8080. It's going to depend on the backend service because now that backend API, if that's not up and running, then obviously our front end client won't be able to do anything. It also has a restart and the custom network, and then an environment variable here. Now, I did actually forget to go back and do this, so let me pop in and fix that really quickly. So we have a, if you remember right, in our application, our front-end application, we specified the web client bean to look for localhost port 8081. for our backend service. Now, this works great if you're running all locally, but not so much if you're running, for instance, in Docker containers or remote servers or even the cloud. That local host is not going to find anything. So one way we can add a little bit more flexibility in, you could ramp on up and use something like service discovery, which is probably the more kind of professional approach to use. But one way you can kind of get around this to provide some flexibility without a whole lot of extra stuff is we can say, look for an environment variable called backend.hostname, and you could call this anything you wanted. If it doesn't find it, it's going to use localhost for the value. And then we're going to say this is private. We're just going to attach this basically to a variable name. And then here we can plug this in and say host name in the middle here. So now it's going to go wherever that host name happens to be, whatever we specified. If it finds a backend host name environment variable, it'll use the value that's that. Otherwise, it'll use localhost in there before that port 8081. So it'll be a little bit more flexible. Now I will need to rebuild that jar file here since I changed that. Almost forgot that little change. And then once that completes, then we should be good to go, and I can run the Docker Compose. So now I should be able to, let me just go back to my main project folder here. I should be able to run Docker Compose up -d. And because I'm building from local folders, I want it to build each time I'm going to run this command. So I add that -- build onto the end. And hopefully this all works. This is the part that if it's going to go wrong, this is where it goes wrong, because Docker is finicky in my mind. So we'll get that spun up. Oh, that's taking a long time. That does not give me warm fuzzies. What did I miss? Goodness gracious. Oh, this is much slower than what it has been. Nothing like a live demo to introduce all the problems. Okay, that at least looks good. I did do this once, and I ended up I copied the same Docker file in, and it did not like that. But that should not be the problem this round, because I fixed that. Oh, there it goes. Hello. Okay, so now we should be able to go over to, I have no idea why that took so long. Over to we could test our port 8081. Look at that. Okay, so our backend service is working. Again, we're not running this locally. Remember, I stopped those applications. We are now running within Docker. And so now let's run our front end client application. And you can see we still get those reviews coming back. So again, we've got that all of this running in Docker. It's our front end application is pinging our backend application, which is then reaching out to config server, grabbing the credentials for the Neo4j database, and then backend service goes to Neo4j database, grabs the data from there, and then passes it back on up to the front end. So with that, let's dive on over to our last slide and just showcase a couple of resources here. So all of the code that I wrote for today is in that first GitHub repository link. If you want to see this full project, so I've got multiple levels. I've included things like MongoDB and Eureka, service discovery, and some other things in there as well. I go much more in depth on config server and clients and so on in the full rendition of the code, which is there at the second link. I also talk a lot more about a lot of the things I had to skim over today in my blog post. So feel free to check out my blog there. Some of this stuff is also available in other places, but my blog, everything is centered there locally. And then if you want to spin up a Neo4j Aura DB free tier database, just like we were running today for the demo, feel free to follow that last link. And again, my contact information is there in the lower left. I will pop into the chat and answer all of your questions, I hope. And thank you so much for attending, and enjoy the rest of Nodes.